you know that 60% of the time statistics are made up on the spot? Or is it 70%? And if you're an Anchorman fan, you'll know that 60% of the time it works every time. And I suppose scientists are always after the truth, aren't they? They want to establish what the truth is. And when they get the vaccine for the coronavirus, they want to know that it works. So what they're going to have to do is do clinical trials, that is, take 1,000 people and give them the vaccine, 1,000 people and not give them the vaccine. And then if 550 people survive without the vaccine and 555 with the vaccine, is that a significant difference? Or if it's 800 and 200, is that a significant difference? At what point do you say the vaccine works? And really that's why statistics is so important.
Okay, try this. Think of an animal. There's mine. Now think of some feature of that animal. There's mine. And now think of some measurable aspect of that feature. I'm going for length. So if we were to take every elephant in the world, chop off their ears, and measure the length of those ears, there'll be some record-breaking elephant with a very short ear, there'll be some record-breaking elephant with very long ears, but most of them would be in the middle. This is what we call normal distribution. And this will be true for any example that you thought of. So if I wanted to describe this population of elephants' ears to someone, how could I do it in a sort of mathematical way? Well, as you probably already know, I could look at the mean, mode, median, and the range. That's from the shortest elephant's ear to the longest elephant's ear. And that would be a way of describing the population. In mathsy terms, the mean is referred to as x bar, and that equals the sum of all the values divided by the number of values. So in mathematical terms, that's x bar equals the sum of x divided by n. But what happens if you got two populations that had exactly the same mean, mode, median, and range, but were obviously different distributions? For those of you who like to show off in University Challenge, these shapes of graphs are known as leptokurtic and platykurtic. So what we want is something else, something that will describe the distribution of values around the mean. In other words, how many values are how far away from the mean. This figure is called the standard deviation. In maths terms, standard deviation equals the square root of the sum of each value of x minus the mean, all squared, divided by the number you have in the sample. Standard deviation is often given the symbol sigma from the Greek alphabet. So standard deviation is a number which reflects the spread or dispersion of the values. And it's quite useful because if you only had range, then an elephant with outrageously long ears or short ears could give a skewed picture of that population. That's why SIA want you to understand why standard deviation might be a more useful measure of dispersion for a given set of data, for example, where there is an outlying result.